Hello all. In our last video, we have seen the topic exception and processing and difference between interrupt, fault, trap and abort. Now, our today's topic is interrupt task and interrupt procedure. That is again from your fourth unit. Now, what if when interrupt occurs? Then following actions must be taken when your interrupt occurs. Step 1. The current address and the flag are saved onto the stack to allow resumption of the interrupted program. What does it mean? When your processor is executing one particular program and the same time interrupt occurs, then processor has to save its current address and suspend the working of the task, and it should serve the interrupt first, and again it can resume the interrupted program. Now in step second, a 8-bit vector is supplied to the 80386 processor which identifies an appropriate entry in the interrupt table, and then the program control transfers to the entry point to start the execution of the interrupt service routine. In the third stage, at the end of service routine means it is an instruction to serve the interrupt. The I return instruction is executed to find the old state, and the interrupted program execution resumes at the appropriate instruction. In this way, interrupt is served and the processor resumes its normal program. The 8-bit interrupt vector is supplied to the 80386 in several different ways. First of all, software interrupt. As we all know, the software interrupt occurs in your program in the instruction. Int instruction contains the vector. Now, what is vector? This vector is having all the information about your interrupt. Exceptions supplies the vector internally. Now, vector, as we all know, our processor operates in three different ways, three different modes. First one is your real mode, second is your protected mode, and third one is your virtual mode. Now, when your processor is in real mode, it uses the IVT, interrupt vector table, which is having all the interrupt service routine or interrupt service instructions. When your processor is operating in protected mode, it is having IDT, interrupt descriptor table, which stores the interrupt or exception handling routine. Now, our second topic is interrupt descriptor table. This is very important topic as the exam point of view. As I told you just now, the protected mode, in the protected mode 80386 needs at least one IDT. At least one interrupt descriptor table should be there while your processor is in your protected mode. The formal definition for IDT contains group of descriptors that define interrupts or exception handling routine. When your exception occurs or interrupt occurs, it should be served by the processor with the help of interrupt or exception handling routines. Those routines are in your IDT, interrupt descriptor table. Now the basic function of this IDT is to hold the segment descriptor that define the interrupt or exception handling routine. Now the interrupt trap or task gate descriptors can be present in your IDT. This IDT can reside anywhere in the physical memory As we all know, your 80386 is having 4 GB of physical memory, right? Its address is stored into the IDTR. This IDT uses the IDTR interrupt descriptor table register to store the content of the IDT. Now there are 256 gate descriptor in your IDT, ranges from 0 to 255 type. Now you must be clear about IDT and IVT. When your processor is operating in protected mode, it uses IDT. Whereas your processor is in real mode, then it uses IVT. Both are the same. Both stores the interrupt handling routines or the instructions needed to handle the interrupts. Now 80386 is having GDT, LDT and IDT tables. Those tables can be loaded anywhere into the physical memory. To locate them, we need 3 registers, GDTR, LDTR and IDTR respectively. Each of these registers store 32-bit linear address. Here is the diagram which shows the descriptor tables and descriptor. Before this, you must know what is descriptor. As we have already seen in your second and third unit the descriptor concept. Descriptor, it means it stores some information about the segment like code segment, data segment and stack segment. It describes or it stores the information. This descriptor is one kind of data structure, right? Every descriptor is 8 byte long and this descriptor is contained in your GDT, LDT and IDT, or we can say it is an element of your GDT, LDT and IDT. This descriptor provides processor with the data that it needs to map logical address into linear address. It can store the information of 3 types. First of 20-bit limit, second field is 32-bit base address and third field of this descriptor is access write byte. In this way, now you can see the diagram. Here we are having IDT and GDT. IDT is having many descriptors. Likewise, GDT can have many descriptors. The information of this IDT and GDT can be stored into the IDTR and GDTR registers. Now, there are 3 descriptor tables, GDT, LDT and IDT. First of all, we will see what is GDT, that is Global Descriptor Table. You can see this rough diagram. The GDT may contain many LDTs. LDTs are inside your GDT. This is most important table of descriptors. It contains the list of segment. Every descriptor is of 8 byte, right? Means the length of the descriptor is 8 byte long. In this way, GDT can contain maximum of 8192 descriptors. As every descriptor is 8 byte long, this is multiplied with 8192 and will get approximately 64 kilobyte long GDT. The maximum size of your GDT can be this much, 64 kilobyte. It can contain special descriptors also, special system descriptors. Now, what is interrupt descriptor table? As we are saying, there should be one IDT in the 80386 while operating in protected mode. IDT maintains interrupt service routine. Those interrupt service routine will serve your interrupt or exceptions. It holds segment descriptor for defining the interrupt or exception handling routine, like interrupt descriptor, trap descriptor, and task gate descriptor. These three concepts we will see later on. This IDT can contain 256 gate descriptors, one for each interrupt vector. Now the user can never select a descriptor in the IDT. Likewise, user can select a descriptor from GDT and LDT but can't select the descriptor in IDT because your IDT provides the interrupt service routine. Those user cannot select. Now the second and the last point is the local descriptor table. LDT can be smaller than or larger than the GDT. As we all know, there may be many tasks running by the processor. Every task can have its own LDT. Means many LDTs can be there in the processor. LDT is used for expanding the number of available segment descriptors with GDT. It is a private type of table. It stores the information about particular task. Every task is independent task. Therefore, the LDT is private table. It contains, likewise your GDT, it contains 8192 descriptors, making this LDT 64 kilobyte long. Means 8 byte wide descriptor into 8192. Approximately it gives 64 kilobyte long. This can be the size of your LDT. Thank you.